All right, so you are, amongst many people, one of the foremost experts on zero-knowledge cryptography and research. Do you mind explaining to our audiences here what the fuck is zero-knowledge briefly?
Sure. I would definitely not say I'm one of the foremost. Actually, there's a lot of people who know like a lot more about this than I do.
To be fair, like you've written a lot of blogs, you've written a lot of
what I've tried to do is like maybe bridge the gap a little bit, exploring different parts of the space and trying to bridge the gap between sort of the CK pill world and the sort of more normal tech world, if you will.
The ZK pilled?
Yeah, so what I mean by that is basically, let's start off with like zero-knowledge proofs. So basically what it allows you to do is that you can prove any arbitrary statement without revealing anything but the fact that it's true. And it's very, very powerful. So like, for example, if you have a passport or something like that, you can prove that you're above the age of 18, but like revealing nothing else. So like normally, if you, let's say you try to enter a bar or something, you would give sort of the guard like your ID, and it might have personal information there, like your full name or your address or something like that. And that's not necessarily information you want that person to have. And like even beyond that, like say you do some kind of KYC thing online, you have to scan your passport or these types of things. And
scary.
That's a big problem in general, but what's not true is basically you can prove the thing that you care about and the thing that you actually want to communicate. So in this case, what you want to communicate is you just want to show that you have a valid passport and you're above the age of 18. And that's all that matters. And that's really all that should be communicated. And this technology allows you to create proofs like that and use it as a building block. So it's a very, very powerful primitive. It's kind of magical in the sense that like, how is this even possible? And it's also magical in terms of how useful it is. So because not only can you prove sort of anything and sort of choose what information you reveal, that's kind of a zero-knowledge property, you can also do so in a very, very small space. So like you can compress something down. And this is very useful in lots of applications. So for example, if you have the Ethereum blockchain, and one big problem is that it's only has sort of limited space. So you want to find like ways of increasing sort of throughput and decreasing cost and solving sort of scalability in general. And one way you can do that is with zero-knowledge proofs, because you can basically prove that each state transition has happened correctly. And the proof for that is like constant size, it's succinct. So no matter if you have like one transaction or 100 transactions or a million transactions, the proof that they were all validly executed all fits in the same space. So that's kind of a crazy property. You kind of create this succinct proof, and then you can put it on a blockchain and so on. So it's a very, very powerful technology, and it's kind of magical because it's how is this even possible? And
moon math.
Yeah. It's a very, very useful building block in terms of how we create these kind of trust minimized systems and how we can scale trust and removing the reliance on trusted third parties and so on.
Trusted third parties are security holes, according to Nick Szabo.
Indeed, yes.
Why is zero-knowledge technology especially like exciting for crypto and for the tech world at large? I guess you kind of answered that.
No, but it's a good question. So I think, and also the reason, like this is kind of fairly new applied cryptography. Like usually when you get new tools like this, it takes like a long time for it to get adoption and funding and so on. But I think with the blockchain space, there's kind of a very nice symbiosis going on. And the reason for that is because blockchains like Ethereum and so on, they have a specific strengths, right? Like it's transparent, which is very useful. You can it's auditable and verifiable and so on. And it's also censorship resistant. So you have all these copies in the world, and like even if you attack one single node, that doesn't sort of change the integrity of the chain. But obviously that has downsides. And I think what zero-knowledge proofs do is they complement very nicely, because you get, instead of transparency, you actually get privacy. So you don't want everything to be transparent. So you can sort of get this privacy property. And the other side of it, like censorship resistance, that requires like having limited space. Like you can only have a certain block size because you need to keep all these copies and it needs to propagate in this network and so on. And by having this succinctness property, we can make the best use of that limited space we have and make it as useful as possible, basically.
Wow.
So they are very complementary technologies, I would say.
What's the most exciting, in your opinion, thing that's happening in zero knowledge right now?
Yeah, so just going briefly back to sort of when I mentioned the CK pilled aspect, it's a very different kind of mental model. And CK is just one of these technologies. Like there's a lot of other types of technologies that all are under this umbrella of like programmable cryptography, if you will. And it's the kind of mental model in terms of how you build systems, because traditionally in the web world and so on, you build up these databases and you trust these companies to safeguard your data and so on. And there's like a lot of assumptions. So like in a well-regulated society or system, this works fine because you have like rule of law and you can sort of, if you sign a contract, you know what it says will happen. Mm-hmm. But there's like a lot of edge cases. And if something goes wrong, it kind of propagates. And in this world we live in, where sort of everyone is, you're from Canada, I'm from Sweden, we're in Taiwan, this is all online and so on, and outside of sort of normal jurisdictional boundaries, it becomes very, very hard to reason about them. It's like sort of knowing who do you trust and why do you trust them. And even thinking about that is very, very difficult. And what this type of technology allows us to do is that we can trust the math as opposed to trusting humans or policies. And it's a very, very powerful concept because it's a way of sort of scaling society, if you will, and doing more things with sort of these more basic, more reliable kind of building blocks. So yeah, just a bit of a tangent there, but just in terms of how to think about this. And I think this type of mental model is not something that most people have because it's kind of new, kind of alien technology, and it takes a while for people to like understand how new technology, like when computers came to life, and then internet and so on, and now AI. Like anytime that new technology comes online, it's kind of people need to get used to it, and it's like develop new mental model. Yeah, it's like a skill problem and like a literacy problem, and just need to get used to it.
If people were interested in, testing out this new alien technology, like what are some apps, what are some use cases you would recommend people to check out that is in the realm of zero knowledge or programmable cryptography?
There's many, and I probably forget a bunch, but like a few.
Your most exciting, like.
No, so I think what basic fun is like private money. I think that's like a very simple and key one. That's kind of the origin of it's not proof. So with things like Zcash, and the basic idea, right, is that when you have something like cash and you pay for coffee, you sort of don't get the history of that whole where that bill has been and so on, like or your paycheck or anything like that. You just pay for a transaction and for a coffee or whatever, and that's it. While public blockchains like Bitcoin and Ethereum, they're great, but they have this problem that is kind of transparent. So like if you get some income or you have some assets, that's kind of follows you around forever, and it's kind of a big problem in terms of just security and so on. So just having this like fungibility property where there's no difference between one ETH versus another ETH or what have you, that's like a very core, very useful property to have. And one way to get that, one of the best ways to get is through zero-knowledge proofs, and that's how it works, for example, in Zcash. And you can get similar things in Ethereum with sort of things like previously to Cash, but now Railgun. You've done an episode there before.
Yeah, shout out to Alan and Railgun.
Yes, indeed. Privacy pools and so on. So yeah, I think you've had a few of these on your channel already. So those are good examples. So I think that's like a big class of products in this space because it's like a very simple way, relatively speaking, sort of get this kind of private moneyware aspect where you sort of can't see the transaction trace and so on. Another class of applications are interesting when it comes to like private identity, if you will. So oftentimes now you have to identify yourself for various reasons. So it's some kind of KYC process, or maybe it's a kind of Sybil resistance thing where you want to make it expensive for people to create accounts on Twitter or whatnot. And current solutions are not necessarily great because they sort of require us to give up all of this data and hack and information. Yeah, there's like a lot of problems with it, right? And
can I just add to what you're saying there? Recently, 90 Seconds of Crypto was accepted for the Gitcoin grants round, privacy round 24. And in order to vote, thank you. In order to vote, though, you have to mint a Gitcoin passport, which requires you to do privacy-preserving KYC. Actually, I'm not going to talk shit about Gitcoin here, but they require you to do privacy-preserving KYC. Yeah. And, I don't know exactly how privacy-preserving it is. I don't know if it uses zero knowledge. So, there's
aspects of it that are used to zero, yes.
Oh, really? It does? Yeah. Oh, okay. Yeah. I wasn't aware. It looked like it was just some, Web2 company, founded in SF that was doing the KYC process.
It's been a while since I looked at it specifically. I do think there are certain components there that using CKB, But it's like a mix of factors, I think.
I see.
Yeah, so this a bunch, and for context, with Gitcoin Passport, it's like trying to take all of these factors, like on-chain activity and like ID and GitHub activity and so on, and
to prove unique humanity.
Yeah, basically, exactly. Yeah. But in terms of as a building block and these products, there's a lot of CK identity solutions. So there's things that are built on your passport, like Open Passport. There's Rarimo, for example, and what they do is they allow you to sort of prove that you have a certain passport in this case. And that's very useful. And one example is Rarimo. It was used in 3 different jurisdictions. So it was used in Ukraine, Georgia, and Russia. And a lot of things have changed geopolitically there, obviously. But what's interesting about that, I think, is that the same technology is being used in 3 very, very different places. Mm-hmm. So in the case of Ukraine, it's more symbiotic, if you will. There's collaboration and so on. In the case of Georgia, I think it was used for things like liquid democracy. This is a few years ago. And then in the case of Russia, it's obviously a bit more adversarial, but it was still able to use the same kind of technology to have some separate election and stuff like that. Yeah. So it's things like that. It's also Zcash that's used in some, or used to be used at least in some crypto conferences. There's a bunch of general CK identity products and various collaborations collaborations with governments, where basically people want some notion of identity or multiple notions of identity ideally, and you want to maintain these kind of privacy properties around it, so you don't sort of leak identities, but you can still use it as a building block for example, cyber resistance and stuff like that. Third one, I think, is like when it comes to like, so I think you have had CKP2P before. I think that's like a great example as well.
Great product. Check out that video.
Yes, check it out. Link in the bio description. No, thumbnail up here. Yes. Yeah. Up here somewhere. And that's very cool because it allows you to sort of do this peer-to-peer on and off ramping. And it's done in a very permissionless way, right? So it's using CK email as a building block, so you can prove that you've received a certain email. And that in itself is like a super powerful primitive. You can prove that you've received like a plane ticket or a conference or whatnot, or that you belong to certain organization and so on. And also things even more powerful like TLS Notary, and there's a lot of other CK TLS products.
That shit is so cool.
It's really cool, and it basically allows you to prove that some data is authenticated, basically. So if you have, say, your bank account, you can use it to prove that you have a certain amount and then potentially apply for a loan in some other system and so on. So a lot of this is still fairly early, but like in the case of CKP2P, it's like live and people it's like real money and it's audited and all of these things. But I think that's a very exciting area as well, where we just scratch the surface. And then there's like a lot of other things, like obviously it's used for scaling. It's a very useful thing because as more and more people want to come on chain, you need to make things more scalable, you need to have higher throughput and just cheaper transactions and so on, while still having these kind of strong security guarantees that we want. And then there's even more, there's like a lot of institutional use cases as well that are very interesting. We can talk more about that later as well. Yeah. It's useful in lots of various contexts, and we just see more and more, especially as the technology matures and people wrap their head around like how to use this technology and build new fundamental building blocks.
And wrap their heads around just how impactful this type of technology really is. So in your opinion, what is the moment when the scale will just tip over and then zero knowledge will just become everything everywhere all at once, and people won't even have to think about it, and underneath everything that they do on their phones or on their computers is just all zero knowledge stuff?
Yeah, I think it will happen sort of gradually. I think it's already happening. Like you mentioned, for example, Git Compass. Now there's like some kinks to work out, but like there are some CK there, right? And we didn't that's one example, right?
Yeah.
A lot of it comes down to UX, and there's obviously like hard technological challenges to make it performant enough to be useful and so on. But for a lot of applications, we're already there, and it's more about sort of the final touches and like various products finding product market fit and so on. But like I'll give one example. So this is more from the Zcash world, but they have this wallet called Zcash, and
shout out Zcash.
And they make this mobile wallet, and it's really cool because it sort of has Tor built in from scratch for sort of private networking. You sort of don't leak things to Infer or Etherscan and so on. At least not as much. And then also it encourages you to shield your assets. So sort of putting them in this kind of private pool of money. And it's very, very easy to do. It's literally just like a button, like your money is not safe. Click a button, and you click a button and then they do it for you. And that type of UX I think is great. And I think we'll see more and more of that, especially as people feel like they can trust this technology and wallets start to integrate it. So like there's a product at EF, for example, called Kohaku that's like trying to push the envelope on some of these things. And integrating stuff like privacy pools or railgun and stealth addresses sort of as default. So it's not something you have to go out of your way, but it's just something that's there. Right. And I think we'll keep seeing that more and more, starting more from the crypto space, but then also specific institutional deployments and then more and more in other scenarios.
So it sounds like you're saying that it's already happening.
It's already happening,
and it's just sort of snaking its way throughout the technology world.